Hello everyone, this is Abhijan Rukia. Today I am going to present you a mathematical model which comprises mathematical problem, its solution and its applications. So without wasting our time, let's dive deep into the ocean of mathematics. My project is the building construction model. Starting with the introduction of the problem. The building construction is a mathematical model with a solution which describes that construction of a building can be completed within stipulated time limit by doing work at constant rate of time. The details of model can vary, but the typical form of model is as described. The investor wanted to build the tower, so he hired the constructor. The investor wanted to build the tower of height 550 meters, but the constructor and his laborers were lazy that they built only 50 meters after long time. So he hired another constructor, and while hiring he kept one condition in front of him. He wanted to complete his building work in 420 days. Now let's have a look at the formal statement of the problem. The constructor agreed the condition. He did some calculation and started the work. Now if we focus the light on the formal approach of this problem, then it would be something like this. We want to build the height of tower 550 meters and the time which is required to complete the tower is 420 days. If we suppose that initial height of the tower is 50 meter, that is at time t is equal to 0, and the rate of change of height of tower with respect to time is 0.5%. Therefore we can say that the rate of change of height with respect to time is 0.005 times t. Here the given time t is in days. So here is the analytical solution of the problem. As we have seen, dh by dt is equal to 0.005 t. So by separating variable method, dh is equal to 0.005 t dt. Now by putting integrals both the sides, we get integration of dh is equal to integration of 0.005 t dt, and after simplifying this we come at a result h of t is equal to 0.005 t square by 2 plus alpha. Here alpha is the integral constant. By putting the initial conditions, that is time t is equal to 0 and height h is equal to 50 meter in above equation, we get the value of alpha as 50. We substitute the value of alpha, that is alpha is equal to 50 in equation 1, so we get equation 2 as h of t is equal to 0.005 t square by 2 plus 50. Now let us find the time to build the building of 500 meter. By putting h of t is equal to 500 meters in equation 2, we get 500 is equal to 0.005 t square by 2 plus 50, and on simplifying this equation we get t square is equal to 1,80,000. Now as time is always greater than 0, we result at an approximation of time which is 424 days. But the consumed time is more than the assumed one. So we need to find the rate at which the goal can be achieved. Now suppose new rate of change of height is p. Therefore dh by dt is equal to p into t by 100. Therefore 100 dh is equal to pt dt. By integrating this and simplifying the equation, we get 100h is equal to p into t square by 2 plus phi. Here phi is an integral constant. By putting initial conditions in equation 3, we get phi is equal to 5000. Now we need to find the rate of changing of height for building 500 meter height in 420 days. So by putting h is equal to 500 meter and t is equal to 420 days in equation 3 with phi is equal to 5000, we get this equation, and on simplifying this equation we results on P with an approximation of 0.5102. Therefore, constructor should work at the rate given by equation 5 in order to complete work on time. Thus, the problem is solved. This model has also its applications in various fields like production of food and measuring the speed of the vehicle. We can also measure the consumption of the raw material by taking it as a function of height. So you can see a simple mathematical model can have its applications in various fields. That's all for the presentation. I hope you enjoyed it. Thank you.